Good morning, everybody. Welcome to 12.3. This has got to be one of my favorite lessons the whole year. And I'm not even kidding. All right, this is called inscribed angles. Inscribed angles. And all I want you to think about the entire day is the angle is on the circle. The angle is on the circle. What does that mean? Well, we're going to figure out how to find out how big angles are if they're on the circle. So, if, for instance, this angle right here, boop, boop, this angle X is on the circle. See, it's on. It's right on. Here's in, here's on, here's out. Tomorrow we'll learn in and out, but today we're learning on. So there's many different ways that a circle can be, an angle can be on the circle. But here is way one, and this is the rule right here. And this is the coolest thing ever. If you have an arc AB, and you know how big the arc AB is, the angle is always the same. Dang it, I almost messed up. Half of the arc. The measure is always half of the arc, always. So if this is like this is like 90 degrees, that's 45. Well, it looks like obviously it can't be the same as the middle. Ooh, I can prove that real quick. So if we've got, not prove, but just show. So let's say we've got this little picture here, and you're like, oh look, that's a 90. Oh look, that's a 90. That's a 90. That's a 90 right there. Well, if you pull an angle all the way to the other side, that's not going to be 90. Look at that thing. It's so small. In fact, it's exactly 45. Isn't that cool? No matter where you go, your angle is always half. Now, this is really cool. So let me show you a couple examples, and then we'll do it. It's like, well, what about this other four? If that's all it is, well, watch this. So let's say something nice and simple, like this is 60 degrees. Now I gotta think here for a minute, because I'm imagining a 60. I'm imagining a 60 as a central angle, maybe something like this. And like, oh look, that's a 60-degree angle. I wonder how big this angle way down here is. Oh, well, this angle right here, because it opens to 60, is a 30. That's it. You're like, oh, but what about if you've got like, this is like moving, sorry. What if you've got like, I'm going to pin it down over here too. What if you've got an angle that is, I'm going to pin it down over here too. I like this brown paper, but it moves. Oh crap. I mean, nuts, sorry. What if you've got, there we go. What if you've got an angle, what if this is like, oh my goodness, what in the world, this is so big, and I'm imagining to myself that this is, oh look, it's like 120 degrees. Now remember, if you put an angle on a circle like this, the 120 goes to the next 2 points. Well, the rule says half of AB. Well, it looks like AB is 120, so this is going to be 60 degrees. That's it. That's it. That's it. That's it. Now conversely, of course, let's say I got a cute little angle over here, and this little angle over here is like 40. And then you're like, oh, well, look, that's 80. Right? 40, 80. And you're like, oh, but could I figure out how big this arc is over here? Well, of course you could. It's 100, because shouldn't a diameter equal 180? That's still true. Shouldn't a diameter equal 180? And that's 120. And you're like, oh, look, man, wouldn't that be 120 in here as well? Of course it would be. Wouldn't that be 60? And it all makes sense. Everything matches. And you're like, well, what if I asked you to find that angle right there? Well, you know that angle right there is 30, because that's an isosceles triangle. Because you've got this, what's it called? What's it called? Radii. Radii of a circle are congruent. Okay, so rule number one. But then rule number two is what happens. This isn't like a rule number two. It's called a corollary, which is kind of a cool word. What happens if you've got something like 80 degrees, and you have an angle over here, and you got an angle over here, and you get an angle over here. Like, how big would this angle be? Well, this angle here, what does it open to? 80, so it's 40. This angle here, what does it open to? 80, so what is it? 40. What is this angle here? Open to 40. Okay, so all of this to say, if you've got angles that open up to the same arc, they're the same measure, and they're both half. So it doesn't even matter really what these are, but these are always going to be the same because they open to the whoop, whoop, and whatever this is, they're both going to be half of that. Okay, that's kind of cool. The next guy, now this is called Thales theorem, and this is like the coolest thing ever, okay? You thought it was cool when we found the infinite Pythagorean triple generator. This is the infinite right angle generator, and this is so cool. Watch this. This is a diameter. How big is the arc of a diameter? You're right, 180. Now watch this. If I pull an angle off of the diameter, this angle here is half of the arc it opens up to. But the arc it opens up to is the diameter, which is 180, so that's got to be 90. What? Oh my gosh, wait, let me try that again. So if I pull one over here using the corollary we just did, that will also be 90. Guess what? You have now found an infinite number of right angles, because even this way, no matter what way you pull, it's going to be 90. So Thales theorem says if you open up to a diameter, you're always 90. Okay, so half of the arc, half of the arc, half of the arc, everything's swimmingly so far. Now this one is super cool. Watch this. This one is about an inscribed, and that's what this is called too, an inscribed angle. Inscribed quadrilateral. Okay, now watch this. So I'm just going to put a random quadrilateral in here. Doesn't even matter really where it is. And I'm going to say something like, all right, let's call, I got to find a good one here. Let's call this right here, let's call this right here like 70. Now, you know, if this is 70, that this will be 140, that whole thing right there. So let's say that this guy is like 60. Okay, that means from here to here is 60. This is interesting. And let's say that this guy, I'm going to be making this up as I go here. I hope that's okay. Okay. Okay, let's see if this works. Okay, so 70 doubled is 140. Well, if that's 140 from here to here, and that's 60, that means this one has to be 80. All right. Now, interestingly enough, we already know the whole circle has to be 360. 120, 200, 260, 360. That means this angle has to be half of, oh, what do you know? 80 is half of 160. 70 is half of 140. What is half of 220? 110. What? Look at those two angles. They add up to 180. Supplementary. And then you're like, oh, that one's got to be 100. Well, of course it's 100, because 100 is half of 200. Of course it's 100, because the quadrilaterals add up to 360. Of course it's 100, because, here's the rule, opposite angles of an inscribed quadrilateral always supplementary. Isn't that the coolest thing ever? So if this is x, this guy right here is 180 minus x. It's the coolest thing ever. So you could just go, they could just go like, hi. Oops, sorry. Hi, here's a cute little circle thing, and this angle right here is 91. You're like, boom, 89. Just like that. Just like that. You just know that they're going to be add up to 180 because that's what they're like, hey, this one's 90. Boom, this one's 90. Just like that. Just like that. And you're like, oh, I want to prove it. You want to prove it? You want to hear a proof? Yeah, you do. All right, check this out. This is actually the coolest thing ever. So let's say, proof time, proof time, proof time. So let's say that this is x. Well, if this is x, that means from here to here is going to be 2x, n'est-ce pas? Okay, so whatever this is, you have it to get to here. Now, that's all the way from here to here. Now, that's really cool. But if that's true, that means that 360 minus the 2x is the leftover bits from here to here. You're like, all right, that's fine. But if you regard this angle right here, you will notice that this angle opens up to 360 minus 2x. You're like, I thought the inscribed angles were always half of what it opened up to. Well, what does it open up to? 360 minus 2x. And what's half of 360 minus 2x? 180 minus x, aka supplementary. Oh my gosh, we just proved it. Whoop whoop. Isn't that cool? Isn't that cool? All right, last rule. This page is getting so full of beauty and all these rules. Okay, check this out. Last one. You say, well, what if my angle's not on like that? What if my angle's on like that? Like it's created from a tangent and a chord. I'm like, what? All right. This is really cool as well. And I say if the angle is on the circle, the angle is half of the arc. If the angle is on the circle, half the arc. Everywhere on this page right here. Look, half of 220. Oh, half of 120. Oh, half of 60. No matter where you're at. Oh, half of, and this whole thing right here would be 182. I mean, all these different things. So if they give you a picture, oh, there it is. So this is AB. This is still half of it. But notice how it kind of goes out like that. So let's say you've got this really nice little tangent thing right here. And you got this cute little angle right here that you're trying to find. But all they've told you is that like this over here is like 240. And you're like, what? Well, if that's 240, that's the whole thing is 360. And if the whole thing is 360, this part right here is 120, and if this part right here is 120 and this is half of 120, this has got to be 60. You're like, well, did that really work? Well, yeah, check out the proof of this. If that's 60, isn't this linear pair here 120? And if this is 120, that opens up to 240. What do you know? It worked. So then they're like, well, what if we give you some sort of really complicated thing? Now, these aren't the pictures you're going to be getting. These aren't the questions you're going to be getting. But questions like this, if they're like, oh my gosh, what if they give me something like that? Well, if that's 25, does it open up to 50? And if that's the diameter, these are both going to be 90, and just like that. You're like, oh, what if they give me something weird like this? Well, if they give you something weird like this is like super cinchy because it's just, there it is. It's half of 246. Oh no, what if they give me an inscribed quadrilateral? Okay, listen to me. These are supplementary. 90, 90, 58, whatever, 180 minus 50, 122. Look at that. All these different things. So you're going to be getting a really, really cool worksheet that has a bunch of questions like this, and even cool things like this, where